Tag them all? Wearable technologies are making it easier to analyze our process patterns as they become smaller and more cost affordable. Radio frequency ID, or RFID tags, can be active or passive in design, and they're replacing identification badges, carton labels, and license plates. Passive tag costs can be as low as 5 cents per tag. Passive tags are used to capture movements, such as the tags that are placed on the running bibs runners wear in road races. Active tags may capture additional data, such as air pressures and temperatures. These tags can also send out a variety of signal types based on tag status. This visual lists 5 factors to consider when using RFID tags to capture data for layout design improvement purposes. Surgical staff at Celebration Health in Orlando, Florida, have been using wearables for years now to help create operating room spaghetti diagrams and reduce other patient travel challenges. Construction crews wear wearables to track location and the movement of all assets, both human and mechanical. Tagging systems plus GPS are being used more and more to analyze and control traffic patterns. RFID tags are also playing a central role in customer preference analysis, as they can be used to capture a variety of customer preference information to be analyzed for correlation with their buying habits. Nike, for example, tags almost all of their apparel. RFID tags can be part of an invisible perimeter system, such as those used to keep people out of high-hazard work areas. When the geofence or the invisible boundary is crossed by the tag, a notification of perimeter violation is sent to the authorities. This approach can also be used to provide only limited access to certain areas, or to keep assets within a boundary versus outside of a boundary. The goal is to minimize risk and waste, the potential for human error, and to improve process performance. Using wearables to find and fight waste. This graphic lists 5 ways in which wearables are being used to help reduce process waste from a lean layout design perspective. Wearables have been being used as hazard sensors for years, but now both the software and hardware are much more cost affordable. How might you be able to use wearable technology to help reduce process waste and errors? First, we've got human and physical asset location and movement tracking. Tag them all. Eventually, we will tag all human and physical assets. Slowly but surely, we're heading in this direction already. Most human assets are trackable for some percentage of their day by tag and GPS location, and higher value material assets are also now being chipped. If you have locations turned on your phone, you are letting folks know where you are at that particular time. Movement tracking creates spaghetti maps in a high-tech way. Knowing human and material asset locations also helps manage workflow, perimeter access and control, and proximity allowances. A second use for wearables would be PPE ground use compliance checking. Wearable technology also provides a means for detecting when the right personal protective equipment, or PPE, is being worn by the right people in the right places. Electronic geoboundaries, human tag signals, and PPE tag signals are managed by software, with exceptions being identified should they occur. Third, we have security perimeter and safe work zone control. In this application, antennae are used to define the perimeter itself, and all assets in the work area are tagged. Tag coding tells the software if a given tag is approved to be in a given workspace. Notifications are sent to the appropriate parties when exceptions are identified. Finally, we have time-based data capture. Every time a tag passes by a sensor, a computer record is generated. This record contains, among other things, a date and time stamp. If you have enough sensors and/or a strong enough tag signal, a lot of important data regarding asset use can be captured. This data can then be used in optimization algorithms to improve performance.